Graphic communication. What is it and why is it important? Graphic communication involves the use of visual material to express ideas. Drawings, photographs, paintings, and sketches can all be used to express ideas. The drawings of plans and blueprints are called technical drawings, and they are considered a form of graphic communication. To understand what technical drawings mean, it is important to have and use a standard set of rules for drawing and reading these images. What does this image look like to you? Is it a rocket ship? Is it an art easel? Maybe it's fireworks. Or possibly a birdhouse. Is it even a real house? If someone wanted to pay you to build this object, what would you build? You can clearly see why rules on how to create and interpret drawings are very important. To explain and demonstrate some of these basic rules, I will draw a rectangular block. This will be one of 4 different blocks I will be expecting you to draw during this unit. These blocks will be drawn as orthographic projections.
Technical information about the shape and size of a part is communicated through the use of drawings. Simple parts normally require drawings showing only one view of the part. However, as the shape of a part becomes more complex, a one-view drawing may not be sufficient to explain the size and shape of the part. Orthographic projection is a drawing method that allows object features to be projected onto an imaginary plane. Let's imagine that this plane is a pane of glass. If we place an object behind the pane of glass, we're able to trace the object's outline by projecting its features onto the glass, which is our imaginary plane. Before we begin drawing, we need to choose our first view. When choosing the front view, select the view that has the best shape or the most contours, shows the most natural position or use, displays the most stable position, provides the longest dimension, and contains the least hidden features. Select the view that best represents the front view.
Which view do you think is the best view for a front view? View A, View B, or View C? The correct answer is View A. It gives you the widest dimension, it gives you the most stable view, and it has no hidden features.
Now, let's place the object behind the glass and trace the outline. Move this pane of glass to the side. On the next page, you will place View B behind a pane of glass and trace its outline. This is the projected outline of the side view or profile view of the object. Notice that there is a dashed line in this view. Since the cutout is not visible, a hidden line is placed in the view to show a hidden edge. Let's select View C to trace the top view of the object. We can show all of the features of this object with 3 views: the front view, the side view, and the top view. To show how orthographic projection works, we will move the panes and place imaginary hinges between them. This method of projecting views onto an imaginary plane is also known as the glass box theory. Add all necessary dimensions, and it's ready for fabrication.
Hello everyone, this is Mr. Kempton. Today I'm going to give you a short lesson on how to draw an orthographic projection. Now, an orthographic projection is a drawing technique that allows you to show a 3-dimensional object, such as this wooden block, on a 2-dimensional surface. like the paper that's in front of us. So what we're going to do first off is determine which view is going to be our front view. And as you saw in the previous video, generally the front view is the widest dimension view that does not show any hidden features. So we're going to use this view as our front view. We're going to use the top, again, obviously as our top view, and the right side as our right side view. So there is my cube. So I'm going to set it aside now, and we're going to take a few minutes and outline some of the techniques and tricks used to create an orthographic projection. So for our first orthographic projections, we do not need to do any measuring. So I'm not measuring the object at all. I'm simply going to draw a bottom line that represents the bottom of the object, in this case the rectangular cube, and I'm going to draw the sides representing the height, and I'll draw a line across the top to finish off our front view. And notice I'm using my ruler, and I'm being as accurate as I can. So the tools you're going to need for this activity are obviously paper, ruler, a nice sharp pencil, and an eraser if you have one handy, because I'm sure we're going to make some mistakes along the way. So back to our drawing. Our first view, our front view, is done represented by nice, dark, straight, accurate lines. So those represent our object. Now I'm going to take the information that we see on this front view and transfer that information up to give us a second view, which will be our top view. So on this drawing here, we can see how wide the object is, and we can see how tall it is. So its height and its width. So I'm going to use a very light pencil line. You can see that on there. That's good. Very light, because it needs to be a different line than our object lines. And projection lines simply transfer information from one view to another view. So I don't need to measure to make sure everything's the same, but I do need to make sure the width that you see here on my front view is the same as the width you see here on your top view. And just to verify that for us, if I'm looking at my object, there's the front, I'm going to put my fingers right there, and my fingers aren't going to move. You'll notice that the width of the top is exactly the same as the width of the front. So we transfer that information up. Now, what I also need to do here now is draw the depth of the top view. And the depth is the distance from the front to the back. Now again, I'm not going to measure, so I'm just going to look at it and try and make that look proportionate to the actual object. So there we go. I'll draw my lines there. So again, those dark solid lines represent object features or object dimensions that you can see. And the light lines transfer information from one view to another. So we have object lines and we have projection lines. Now here's the tricky part of an orthographic projection. I have my front view and I have my top view, and those lining up with each other makes sense because they are the same width. But now I need to draw a right side view. So there is a trick involved here. And the first thing we want to do is draw some projection lines straight across from any edges or features that we see. So there are no features on this shape, so we're going to keep it nice and simple. So there is the height transferred over, and this is showing us depth from front to back, so I'm going to transfer that information over also. And I'm doing my best here to keep all my lines flat and straight. I don't want to try and draw a line from here and have it go up or down. So you want to keep all of your projection lines and your object lines as straight as you can. And there's a little trick to that. You try and line them up with the edge of your page, and that keeps them perfectly straight, flat, or perfectly straight up and down vertical, depending on which line you're drawing. So once I've got my projection lines drawn over from my top view and from my front view, I'm going to create a 45-degree line somewhere in this area right here. Now, there's 3 or 4 different ways you can create a 45-degree line. The easiest way is if you have one of these guys lying around, a nice 45-degree square. These are called squares, even though they're not squares. And to draw a 45-degree line here, I just set this character down, making sure any one of these lines is straight with my original lines, and I draw my projection line. And that will be 45 degrees. If you don't have one of those around, but you have one of these, a protractor, you can do the exact same thing. You set it down, pick a point, draw it out to 45 degrees, and you'll see here this is exactly on 45 degrees, which is awesome. Now, if you don't have either one of those and you just have a regular ruler, we can still do a 45-degree line. And the way we do that is we pick a point, and we draw over a set distance. You can pick whatever distance you want. I'm going to go over 2 centimeters, and then I'm going to measure up 2 centimeters. That takes me right to there. So you'll see now, if I draw a line between this dot and that dot, that again falls perfectly on 45 degrees. So there's 3 different ways you can get a nice accurate 45-degree line. And it is important that our 45-degree lines are accurate, because that will change our drawing and make it incorrect if it's not accurate. So